Hello there, welcome to my channel. Okay, in this video I'm going to discuss with you about chemistry paper 4 42 October November 2021. Okay, the time duration here is 1 hour and 50 minutes. Okay, let us move to the first question. Okay, question number 1. This question is about state of matter. Complete the table using ticks and cross to describe the properties of gases, liquids and also solids. State of matter, we have here gas, liquid and solid, and particles are touching. So the particles are touching, you should put solid and liquid, okay, and not for the gases. Okay, particles have a random movement. Random movement should be gas and liquid, and we have to put a cross over here for solid. Okay, for particles are regularly arranged. Okay, this is only for the solid, and we have to put a cross over here. Okay, this is your answer. This is for 3 marks. Okay, now let us move for the second question, B. Substance can change state. Okay, boiling and evaporation are two ways in which a liquid changes into gas. Okay, describe two differences between boiling and evaporation. Okay guys, so this is my answer here. So for the first one, boiling occurs at a certain temperature, like water we have 100 degrees boiling point, while evaporation occurs at any temperature. Even if you pour the water in an aircon room in a cold temperature, the evaporation still occurs. Alright, so the second one here is the boiling occurs at fastest rate compared to the evaporation, which will take a longer time. Alright, so you have to compare both of these boiling and also evaporation to get 2 marks over here. Okay, so now number 3, name the change of state when a gas becomes liquid. So this is definitely a condensation. Okay, condensation. And a solid becomes a gas. A solid becomes a gas. This is a sublimation. Sublimation. Okay, example of sublimation we can say is a dry ice. Okay, in case they ask you in your school exams. Alright, so this is the process. This is 2 marks. Okay, now we move to the next question. Okay, C. A substance boils at temperature X. It boils at temperature X and melts at temperature Y. So complete the graph to show the change in temperature over time as a substance cools from temperature A to temperature B. And this is the graph. Here's the temperature and here's the time. Okay, if you notice here, it boils at temperature X. So this is the boiling point. Okay, this is the boiling point. And then here it melts at temperature Y, and so here is the melting point. And if you notice the graph here, it is a cooling curve. Alright, it's a cooling curve. So every time it means they are changing it from the gas to liquid and to solid. So every time when we have a boiling point and melting point, the graph will become a horizontal. Alright, so you will have a latent heat. So let me just draw the graphs so we can continue from here. We make the graph be bigger. Okay, and then from here we can draw the graph is going down to the level of Y. Alright, to the level of Y, and continue with another horizontal line before we go down further to point B. So this is point B. So this is your Y, and this is the B, temperature B. Okay, so this is the graph, this is the cooling curve. Alright, okay, so I hope you can understand this. This is the 2 marks for you. And the next question, a solution is a mixture of solute and also solvent. Name the process when a solid substance mix with a solvent to form a solution. This is definitely a dissolving process. Okay, you can just write there dissolving process. Okay, the next one, name the type of reaction when two solutions react to form an insoluble substance. This is like your salt to precipitate. So here we will have a precipitation. So this is the example of the process number 2. So we will have a solution over here, one type of salt, sodium chloride, and we will have another type of soluble salt, which is argentum nitrate or silver nitrate. All nitrate salt must be a soluble. So when both of them mix, they will get swap between this salt, which is argentum will be with chlorine, and sodium will be together with the nitrate. So here we will have one is solution, another one is a precipitate. So here is argentum chloride and here is a sodium nitrate. Okay, this is an example for the question number 2. Alright, so this is the total marks for question number 1. Okay, now let us move on with the question number 2. Okay, acids are important laboratory chemicals. Some acid completely dissociate in water to form ions. Okay, here's the key word over here, completely dissociates. If it's a completely dissociate, it means it's for strong acid. Alright, if it's a partially dissociate, it means it's for weak acid. Okay, now question number 1, state the term applied to acid that is a completely dissociates. So you should have a strong acid. This is your only answer here. And complete the equation to show complete dissociation of a sulfuric acid in water. So we have here sulfuric acid. So it will completely dissociate. So remember, acid is a proton donor. Alright, it's a proton donor. Acid is a proton donor. So you will have here hydrogen ion plus with sulfate ion. And then you have to, please remember to balance out the equation. So here you have 2, right? So we have to put here 2. Then it's balanced. Okay. So that is the reason they give you 2 marks. One is to write the equation, another one is to balance it. Okay, now state the color of methyl orange in sulfuric acid. So this one definitely should be a pink color, pink or reddish color. Okay, and then please remember this. Okay, for acid, it will show as a pink or red color. In alkaline solution, methyl orange will show it as a yellow color. Alright, so please remember this. Okay, now we move on to the B, section B. Okay, and then here we can see, okay, the equation for the reaction between powdered zinc carbonate and dilute nitric acid is shown. Now you have to complete the equation by adding state symbols. Let me make it bigger. Okay. Alright, for this, remember all carbonate salt, okay, they are not soluble, so it should appear as a solid. Acid, they should be in an aqueous form. Alright, So there is a small difference between an aqueous and liquid. If it's a molten form of a substance, a molten, you should have to write it as a L, is a liquid. If it's an aqueous, you should form as a salt or acid. Like here, we have a zinc nitrate, is a salt. So we have to write here an aqueous. So water is not a salt. Alright, water is not a salt. So we have to write here as a liquid. And carbon dioxide definitely is a gas. Okay, now there is a mole calculation. Let me try to make it bigger. Okay, here I rewrite the equation. Alright, the same equation that you saw on top. Okay, now a student found that 2.5 zinc carbonate required 20 centimeter cube of dilute nitric acid to react completely. Okay, calculate the concentration of dilute nitric acid using the following steps. Okay, now calculate the mass of 1 mole zinc carbonate. So zinc, the RAM for zinc is 56. For C, carbon is 12 and oxygen is 16. So we just have to add on. So zinc is about 56 plus with carbon is 12 and oxygen is 3 times with 16. You'll be getting here about 48. Yeah, I'm very sorry, there's a small error. Zinc supposed to be 65. Okay, here supposed to be 65. So you add on all this, you'll be getting your answer as 125. Alright, so this is your mass. This is your, so here will be 125. And look at here, number of moles of zinc carbonate. Okay, so we have to follow the formula mass over RMM, and here we'll be getting the mole calculation. So mass is the 2.5 divided by 125. So by calculating, you'll be getting here 0.02. Alright. Okay, and then remember from my previous video, most of the question I used to use the ratio in front. So we'll follow the numbers in front here. 1, and if here's 2, put here 2. Here's 1, 1, 1, 1. And if the mole here is 0.02, we just follow the ratio. If it's 1, so here also should be 0.02, 0.02, 0.02. And here it need to multiply with 2. So here you'll be getting there about 0.04 moles. Alright. So determine the number of mole of nitric acid. So here you have a 0.04. Okay, now calculate the concentration of nitric acid. So what we can do over here is the volume is 20 centimeter cube. Alright, so here's the 20 given in the question. So we just have to divide. So we can use concentration equals to mole divided by volume, and make sure your volume must be in a D-metric cube. So which means the mole here is 0.04, the volume is 20, so 20 divided by 1000. Alright, so we have to divide it first, and we will get the answer as 2 molarity. Okay, so you can actually simplify this like a 2m. another form of a molarity. So this is 4 marks. So total marks for this question is 10 marks here. Okay, so we move on with the next one. Okay, atom number 3. Atom contains proton, neutron, and electron. Complete the table to show the relative mass and the relative charge of proton, neutron, and an electron. This is a very basic question, and it appeared in last year February March paper, and also some of this May June paper. So the proton and neutron's relative mass here will be 1 and 1, and here will be positive 1 for the charge for proton, 0 for neutron. Electron is negative 1. Okay, so guys, please remember this. This is 3 marks, easy mark for you, a bonus mark. Okay, now we look at the next question. The table shows a number of proton, neutron, and electron in some atom and ion. Complete the table. So we make the table looks bigger. Right, this is good. Okay, so now this is atom, right? This is an atom, so you don't have any charge. So the proton number is below here, which is 16. Proton number should be equal to electron for an atom, right? So here you have to minus 32 minus with 16, you are getting here 16. Okay, then this is a potassium, and you have a charge there. So if you have a charge, there will be a slight difference in your electron. So here this 19 is a proton number, so it donated 1, right? So if you look at this arrangement, it's a 2.8, it's supposed to be here 2.8.81. okay, this is a 19 for normal potassium. If you have a potassium with charge, it will be donating 1. So here you have 18, right? So here you have 18, the answer. This is just an example, so let me just erase this. Okay, and then for neutron we have to minus 39 minus with 19. Here you'll be getting there about 20. Okay, now for this proton and neutron, we add on together, we'll be getting 79. All right, 79. And here if you look at it, the proton is 35. Okay, and then here there is a small difference where the electron is 1 higher slightly, so you should have a negative sign. So to check out what element is this, we have to go to the periodic table searching for 79 and 35. So this is our periodic table. So 79 and 35. So make it much bigger, and you can see there is a 35 here. Okay, so we have to take the same proton number. All right, same proton number at this part. So here we will have a bromine. So now we go back to the question. So here we will have a bromine. Okay, so this is your answer for this question, and you'll be getting here about 5 marks for this. Okay, now for question number 4. Chlorine react with a carbon monoxide to produce phosgene gas. A catalyst is used. Okay, the reaction is exothermic. Okay, exothermic means it releases more heat. Okay, explain why the reaction is exothermic in terms of energy changes of bond breaking and bond making. Okay, we have to remember this. When you have a bond breaking, alright, when you have a bond breaking, just make it simple as breaking. Okay, when you are breaking a bond, it should be endothermic because you are absorbing the energy. Alright, you are absorbing the energy to break the bond. But when you are when you are forming the bond, you are releasing the heat. So this one will be the exothermic. So let me type the answer since my writing is quite bad. So what I'm going to say here is the bond breaking requires absorbing energy while forming a bond will release the energy. Okay, so this is your first sentence. Okay, the second one here will be, okay, this will be your second point. Okay, first one is you have to explain bond breaking requires absorbing heat and forming a bond will release the energy. Okay, the second point here will be energy released. You have to relate to the exothermic, okay, for your second point. The energy released during forming a bond, alright, forming a bond is larger than the energy absorbed during the breaking of the bond. And so this reaction is exothermic. Alright, so this is 3 marks for you. And let us look at the next one. Okay, complete the energy level diagram for this reaction. Okay, on your diagram shows the product of the reaction, an arrow representing the energy change, label, okay, you need to include this, and an arrow representing an activation energy A. Okay, so what is your product? Your product is phosgene gas. Okay, so all you have to do is you have to draw it, make a hump and a straight line like this, and you can put a dotted line here to show that this is the activation energy. Alright, this is the activation energy A, and this is the, I can draw it here, this is the changes of the heat energy, and we have to put the product here, CO chlorine 2. Okay, so this is your answer. Let me just slightly confirm it again, and make sure put your state of the product. So you must have 3 things over here. This is 1, this is 2, and this is 3. So that's how you got the 3 marks. Alright, so state why a catalyst is used. So you can say it to increase the rate of reaction. So that is your answer for the first one. Okay, now let us move on with the next one. Okay, here D. Describe and explain the effect, if any, on the position of the equilibrium when the pressure is increased and the temperature is increased. Okay, the process is exothermic, so we have to relate the answer with the exothermic process. Okay, let me show you an example. Okay, this is the example of a comparison that I'm going to do. Okay, so here the first is the endothermic. Endothermic means the entire process, it absorbs heat to produce this, okay, to produce the product. So if it's endothermic, it's absorbing heat, so it makes sense if you increase the temperature, you will shift the entire equation to the right hand side. Okay, shift to the right. And for pressure, we have to reduce it. If the temperature increase, we have to reduce the pressure. While for the exothermic here, it is releasing heat, so there is no point of increasing the temperature. So the temperature should be kept under control, and we have to increase the pressure. That's how it will bring things shift to the right. Okay, this is to shift to the right. Anything that happens opposite, it will shift to the left. Alright, so this is only for to shift to the right. So using this, we are going to answer this following question. So if it's exothermic, alright, is for the exothermic, we increase the pressure. We see what happened for exothermic. Exothermic, we increase the pressure. Yes, we will have a shift to the right. So the entire position of equilibrium will shift to right. Since it is a 2 marks here, so you have to include the 2 points. It has to shift to the right, and you have a fewer molecules on the right hand side. Okay. The second one, the temperature is increased. So okay, for exothermic, the temperature is increased. So look at here. Okay, this is for shift to the right. Exothermic, when the temperature is decreased, this is shift to the right. If you increase, you will have shift to the left, the opposite. Alright. So we have to answer here, shift to the left. And the next one here, you can include the reaction is a exothermic. Okay. So now we move on with the next question. Okay, question D. The reaction between chlorine and carbon monoxide can be represented as shown. Okay, when 1 mole of chlorine reacts with 1 mole of carbon monoxide, 230 kilojoule of energy is being released. Some bonds energy are shown in the table. Okay, use the information to calculate the energy of the bond between the carbon and the oxygen in carbon monoxide. Okay, to calculate this, we have to understand the entire equation is more to, it is exothermic, is releasing heat. So let me erase all of this. Okay, now here at the first point here, this one, you have to absorb the heat. Alright, so this one will become the endothermic energy, and here will be the bond forming, the formation of bond. So you are releasing heat, right? So this is the exothermic. So what happened here? The endo will plus with the exothermic, which is a negative, right? You'll be getting here negative 230 kilojoule. So this is your understanding before you do the calculation. So now chlorine and chlorine, so this part, right? So we have here about 240, and here we are not sure, so we are just going to put here X. So your total of endo, alright, your total of endothermic energy here is 240 plus with X. Okay, while here, if you look at it, we have few calculations to do. First thing is, we have carbon and oxygen double bonded. So here we have 745. Okay, then we have to plus with, you can look at here, the carbon and the chlorine, right? So here they have two bondings, 1 and 2. So carbon and chlorine, they have about 400 each. So plus with 400, and here you'll be getting here about 1545. Okay, so this is the for exothermic. Okay, so we just put here, we are going to put here minus. So endo is 240 plus with X, and here we minus with 1545, which is equivalent to which is equivalent to negative 230. Okay, so now we have to do the mathematics. So the x, so you are getting here about x minus 1305, and this one move to the opposite side. We are going to get here a plus of 1305. So the total of x here will be is 1075. Okay, so the answer here will be 1075 kilojoule. Right, so I hope you understand this, and you don't forget to add this one per mole. So this is your answer, and this is the solution. Okay, the marks given here is 3 marks, right? So you can write the answer down. Okay, let us move on with the next question. Okay, complete the dot and cross diagram to show the lateral arrangement in a molecule. The same molecule. Okay, show outer electrons only. Okay, so here we have okay, look at carbon. We have 2.4, the lateral arrangement, right? 2.4. So we need to use only the 4. If you look at oxygen, here they have 2.6, so which is only just show the 6. And look at chlorine, we have about 2.8.7. This is all is a lateral arrangement, yeah. And if you have one bonding, it means they only share a pair, something like this. If you have a double bonding, it means you have 2 pairs of electrons to be shared, right? So let me make the image bigger. Okay, so you can write it down. So here we have X for chlorine. So 1, 2, 3, 4, 5, 6, and 7. This is for chlorine. So same thing, I'm going to do it over here. 1, 2, 3, 4, 5, 6, and 7. Okay, now for carbon we have 4, right? So we have 4, right? Okay, so now we are going to put here a dot. 1, 2, 3, and 4. So for oxygen we need to draw about 6, where you have here 1, 2, 3, 4, 5, 6. So as you can see here, it represents the double bond, alright, the double bond, and here it shows a single bonding. Alright, so I hope you understand how to draw this. So the total marks for this question is 3 marks, and for this question is 17 marks. Okay, we move on with the next one. Okay, number 5. Iron is a transmission element. Potassium is a group 1 element. Okay, iron and potassium have the same type of bonding, which means they are telling us a hint of a metallic bonding. Okay, so both are metals. Okay, now name and describe the type of bonding in these two elements. So we just have to write here metallic bonding. Okay, some of you having a confusion of it could be ionic bonding, right? If it's a potassium, yeah, you could mention it as a ionic bonding, but look at iron, you have a comparison there, so it is confirmed definitely is a metallic bonding. Okay, now metallic bonding, the explanation here will be something like you have let me draw it here. Okay, metallic bonding, so you will have a positive charge of the elements, alright, per positive charge is the cation, and you have a sea of electrons all over. Alright, so this is the bonding that they form. This is a metallic bonding. So let me write it down for you. Okay, so this is my explanation here. A strong attraction force between a positive ion in lattice structure and its sea of electrons. So this is the definition for the metallic bonding. And here we have about 4 marks. Okay, now we move on with the next one. Okay, the transition element and group 1 element have some similar physical properties. They can both be hammered into a shape, conduct electricity, be stretched into wires. Name the term used to describe the ability of element to be hammered into a shape. So it's definitely a permeable. Okay, describe what happened to the particles in iron when it is hammered into a shape. So you could answer. Let me write it down over here. I'll type it for you. Okay, so this is, you can mention it as an atom or particle layers. Okay guys, so this is my answer here. So the atom and particle layers will slide over each another. For example, you have a layers of atoms, right? When it's under the pressure, what happens is they will be sliding each another. So they'll move in this direction. So one is going to the left, this is going to the right, and this is going to the left again. Okay, this is what I mean, a layer of particles or atom will slide each another. Okay, for the next question, suggest why copper rather than the other transition element is used for wires wires which conduct electricity. So we can choose to answer unreactive. Okay, this is correct. And make sure you do not answer this. Good conductor of electricity. This is a big no-no because they are comparing. Why copper rather than other transition element? Remember, other transition element like a silver and gold, they are very good, a better electric conductor compared to copper. Alright, so we cannot answer this. So we have to answer unreactive. Okay, now C, the transition elements are harder and stronger than group 1. Describe how two other physical properties of transition element are different from those group 1 elements. So you can write here, you have a higher density. Okay, they have a higher density, and you can also mention as a higher melting point. Okay, and there are more compression that you can do, like it produces colorful solutions. So okay, so this is your answer. All right, so we move on with the next one. So for D, the chemical properties of some group 1 elements are shown in the table. So we have elements lithium, sodium, potassium, and rubidium. So reaction with cold water, you can see it's a steadily evaporates, strongly evaporates, and very strongly evaporates. And here we have, it forms a colorless solution, colorless solution. So here we can also write down, it forms, let me write it bigger, a colorless solution. And you can also add here, okay, so we can add on here, it forms a colorless solution and also a vigorous evaporance. Okay, so here the color, Okay, the color, okay, the flame test color. So please remember here, for sodium we will have a yellow color, and for phosphorus we will have a slightly purple color. To be make it better, we put here lilac. All right, and then the reaction with oxygen, it slowly forms an oxide, slowly forms an oxide layer, quickly forms an oxide layer. So you have to answer something that it increase the reactivities. All right, example like, so you can answer like rapidly forms an oxide layer. And very sorry for my bad handwriting. So here this is the answer suggested. Okay, so here we have about 4 marks. Okay, and then for this, name the gas produced in a group 1 element when it reacts to water. So you can answer as a hydrogen gas. Okay, hydrogen gas. Okay, name the solution form. So always remember, when you have a group 1, let's say this is a group 1, it react with water, it will form a group 1 hydroxide, and it will release a hydrogen gas. So to make it proper, we will balance the equation, and this is your equation formula for group 1 when reacting with water. Alright, so the solution forms here will be potassium hydroxide. Potassium hydroxide. Okay, and then this is an alkaline. Alright, this is an alkaline solution. So predict the pH of a colorless solution, which is this. So you can answer anything that is above 7. So let's say we just make it like 9. Okay, okay, write the equation, write the chemical equations. We just have to follow this when for the reaction of sodium with oxygen. Oh no, this is different. This is a sodium and oxygen. So sodium plus with oxygen, you will have sodium oxide. So which is Na2NO. Now we have to do the balancing. So how I come with this? You have this. So the negative 2, the 2 will be here, and the positive will be here. So now we have to balance it. Here you put a 2 and a 2 here. No, doesn't balance. So here we make it 2. So now we have a 4 sodium. So we just put here 4. Okay. Okay, now for iron. Iron is a typical transition element. It is a catalyst used in a Haber process. Haber process. Okay, Haber process, you will have a nitrogen gas with hydrogen gas. Okay, this one is to produce ammonia. Okay, ammonia, which is NH3. So you have NH3. Now you have to balance the equation. We put here 2 and we're going to put here 3. Okay, state the temperature and pressure used in Haber process. Include the units. So here please remember the temperature here will be 450 degrees Celsius and the pressure here will be about 200 atm. This is the pressure amount. And here make sure you write it is a reversible process. Okay, so the total mark for this question is 22. Okay, we move on with the next one. Okay, ethanol belongs to a homologous series called alcohols. Write the general formula for alcohol is CnH2n plus 1 NOH. Okay, this is the general formula. Why ethanol cannot be described as a hydrocarbon? Because it contains alcohol. you have sorry, not alcohol, you have oxygen there. Alright, hydrocarbon, it means the molecule, it only has carbon or hydrogen. Carbon and hydrogen only. So ethanol, it contains oxygen. So that is your only one reason. So now ethanol can be manufactured from a different substance by reaction with steam or by fermentation process. Give the formula of substance which react with steam to form ethanol. Okay, so here the formula here will be alkene, you plus with water, then you will have alcohol. So it need to come from a same, if it's ethanol, it need to come with ethene, right? So here ethane is this. The formula of alkane is C2H4. So should be C2H4. So the formula here will be CnH2n. This is for alkene. Name the substance which will undergo fermentation to form ethanol. So you can have a glucose here. They are asking the substance. Okay, ethanol is a fuel. Write the chemical equation for complete combustion. So remember this formula. There's a fuel plus with oxygen. You must have carbon dioxide and water. So they're asking us to write the chemical equation. So it's ethanol, OH, plus with oxygen, and to form carbon dioxide plus with water. Okay, and then don't forget to balance the equation. So if you balance the equation here, you must get, you must have a 2, then here's 3, and here's 3 as well. So carbon done, hydrogen here we have 6, so here we have 6. Oxygen here we have about 7, so here's 4, and here's 3. It's balanced. So this is your answer. Okay, we move on with the next one. Okay, ethane 1,2-diol has 2 alcohol functional group, which is this. Okay, one molecule of ethane 1,2-diol will react with 2 molecules of ethanoic acid to form molecule X. So X has a 2 ester functional group, and the molecular formula of this, you can see it, so it's 4. Okay, so what is ester's functional group? So let us look at a small example here. So ester is formed by, you have alcohol, and here you have a carboxylic acid. So here the formula here will be CnH2n plus 1 OH. And then for carboxylic acid, you have the same, and you have a COOH. So what happened when both of these they combined is the last part of the hydrogen will be combined with the OH. Alright, so I'm going to write here the ester's formula. So here you have plus 1 C double bond O. So I'm writing this, and it will combine with the alcohol after that, and you will have water. The water comes from alcohol and hydroxide ion from alcohol and hydrogen ion from carboxylic acid. So the functional group for ester, this is ester, is this. Okay, this is the functional group. So as you can see here, they have two different group of OH. Okay, so before that we will go through the questions one by one. So here they have a molecular formula of this. Now state the empirical formula of X. Empirical formula is the most simplified, like fractions. You are simplifying the fractions. So C3 divided all by 2. So here you got 5 and O is 2. Alright. So here draw the structure X. Show all atoms and all of the bonds. So structure X. So let me just like okay. So before you do, okay, now here we have the C is 6, right? In total C is 6, which means it have to minus with these 2, right? Minus out the 2, so we have total about another 4C, which is 2 from here this side and from this side. Okay, so let me draw the carboxylic compound here. So here we have example, here we have this. Okay, then the next one we will have this C double bond O, oops, C double bond O with another C. Alright, so now when they combine, you have to remove this. Alright, you will remove the OH from the alcohol, and you will remove the hydrogen from the acid. Okay, so using this, we are going to write show all the bonds. Okay, now this is for the carboxylic acid. 1, 2, 3 carbon double bond with the O, then you have a O here, H, 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 and then you write down the alcohol part. So we have 2 carbon, hydrogen, and we continue with this group. So we have O, carbon double bond with the oxygen, and we have this. Okay, so this is the esters group. Okay, now name other substance formed in this reaction. So definitely you can put there water. Okay, the next one, each alcohol or functional group in ethane 1,2-diol react with acidified potassium manganate to form a different organic compound Y. Name the functional group formed in Y. So always remember, when you have an alcohol and you react with this acidified potassium manganate, you will form carboxylic acid. Okay, you will form a carboxylic acid group. Okay, draw the structure Y and show all the atoms and all the bonds. So you can write down the carbon. So previously we have OH, right? So previously we have OH, and this one will be oxidized to diol. Okay, so please remember that when you have when you're having a carboxylic acid here, you must have this group. Okay, so we have a carbon double bond with oxygen, and here we have a oxygen and hydrogen. So please bear in mind, carbon can only will have 4 bondings, 1, 2, 3 and 4. So here we need to remove the hydrogen. All right, so here we need to remove this hydrogen. So we need to remove the hydrogen here in order to have a double bond of oxygen. Okay, so this is how we can form ethane dioic acid. Alright, so this is how the formula is, and basically this is a more into a A-levels chapter. Alright, it's the A-levels chapter. So I hope you can understand from here. So all the best for your revision, and if you have any questions, please keep a comment below. And thank you for watching this video, and support my channel for further updates. Thank you very much, guys.